Artificial intelligence is the new electricity. That is the transformative influence AI is said to have on our collective society. AI is the new wealth and AI is the new power. AI and the business value that will be yielded from it will be responsible for the largest transfer of wealth since the Industrial Revolution. Companies who understand this, who embrace this, who change their business models in accordance with this, who adapts to this, these are the companies that will thrive, these are the companies that will attract top talent, and these are the companies that will shape the industries of the future. Companies who do not, well, we'll read about them in our MBA case studies like we read today about Kodak and Blockbuster and Toys R Us and Thomas Cook. And since AI is the new electricity, data is without doubt the grid that it runs on. AI systems need data, they feed off data, they cannot exist without data. You might even say data is the very foundation upon which AI is built. But what if that foundation has cracks? What if it's not as solid or as trusted as what we thought it was or expect it to be? What could the consequences of that look like? None of us would build a house on a questionable foundation, so why would it be any different with AI? In the age of AI, bias in AI is one of the most important topics of our time. This is because trusting the outcomes technology solutions provide are essential to the long-term adoption and value realization of those solutions. And in an AI-first world, the same principles apply. So what I'd like to do in the next 25 minutes or so that we are together is to unpack this notion of bias in AI. What it is, why we should care. What does the manifestation of bias in AI look like? How do we mitigate bias in AI? And what could be our potential path forward here? Okay, so let's dive straight in. What is bias? How do we define bias? I thought I understood what bias was, what bias means, until I dug into it in a bit more detail. I've since come to the realization that bias is another one of those nebulous terms that means different things to different people in different contexts. Very much like digital transformation and even AI. So let's have a closer look at a few definitions of bias. In psychology, bias refers to a systematic deviation from rationality. In social sciences, bias refers to the excessive influence of the past on the present. In statistics, it's about results that are systematically off the mark. In data, it's when the sample isn't representative of the broader population. And of course, in AI, it generally refers to algorithms that reflect implicit human values. The problem with bias in AI starts with how we define bias and in which context we use it. How can we even agree on fixing something when we cannot even agree on what it is? So as you can see, this notion of bias is not as clear-cut as what we might think. And it gets even more complicated. It gets more complicated because the dirty little secret very few people in the field talk about is that being human actually means being biased. Sometimes the bias is explicit and other times it's unconscious. So here's what I mean. We are bombarded by sensory information every single second of the day. In fact, about 11 million bits of information per second hit our senses. And the reality is, as human beings, we can only consciously process about 50 bits. So in order to cope, the mind builds routines based on the patterns in data. This is why certain tasks we perform are done on autopilot. The mind is able to switch to what we call default network mode. This is where you perform tasks without conscious thought based on routines the mind has built. You see, inherently bias isn't a bad thing. It's actually a very neat little biological survival mechanism. When we talk about bias in AI, we should be clear that bias doesn't come from AI algorithms. Bias comes from people. It's laced in data and then it's manifested in these AI algorithms. We talked about data being the foundation of AI and that AI systems need data to function effectively. Well, think of data sets like textbooks designed for students to learn from. And guess what? Textbooks have human authors and so do data sets. And just like textbooks reflect the biases of their authors, so data sets reflect the biases of their authors. And we see this manifest itself in society, right? Just look at how MIT recently had to pull their massive 80 million AI dataset offline over racist and misogynist content. We see this in AI algorithms discriminating against classes based on gender, sex, race. We see the consequences of this discrimination. This is why solving bias in AI is absolutely essential to AI success long term. So why is it that bias seems to perpetuate itself regardless of our best efforts? I used to travel with the train into Cape Town CBD. And as it does in Cape Town during winter, it's wet, it's cold, it gets dark early. So one cold, wet winter's evening, I'm walking from the office to the train station when I hear footsteps behind me. I glance back and I see two females. I don't worry at all for my safety. I don't even give it a second thought. Why is it that if it were two males, I'd have a slightly different response? Why is it that if they wore suits, I'd be more relaxed than if they were vagabonds with ruffs? Think about the assumptions, the immediate funneling of information, all based on experiences, knowledge, visual stimuli, environmental stimuli, historical stimuli. Now translate that into an AI-first world where developers who are human and have their own experiences based on their worldview and their own backgrounds and their own beliefs and yes, their own biases, develop AI algorithms and select data sets through that specific lens. That is how bias creeps into AI. We look at it across a three-tiered paradigm. Let's think about framing the problem. When machine learning developers look at developing deep learning models, they usually start with the outcome in mind. This isn't necessarily a bad thing, but obsessing over a successful outcome doesn't necessarily provide the full view of what transpires. Think about an AI algorithm running the dispatchment of ambulances, for example, with an express mandate to prioritize helping as many patients as possible. The algorithm might prioritize patients with small cuts and bruises over and above patients with massive injuries because it can serve more patients that way. It may achieve its goal, but it completely defeats the purpose of the algorithm in the first place. As we move on to collecting the data, there are usually two main ways bias tends to show up when we collect the data. The data is one, either unrepresentative of reality, or two, it is already reflecting existing prejudices. So think about a facial recognition machine learning algorithm being fed more photos of light-skinned people than dark-skinned ones. What happens? The algorithm would perform better for light-skinned scenarios than for dark-skinned ones. Now think about the distinguishment in customer experience when using that technology in a retail store, for example, to identify potential shoplifters, prevent theft and losses, things like that. As we move across to preparing the data, take the process of loans by a bank as an example. When AI developers select which attributes they want their algorithm to consider, age, income, gender, race, educational qualifications, years of experience, all of these are laced with bias. So while the impact on the model's accuracy may be better, the impact on its bias most definitely is not. Think about how this impacts on the overall experience of the customers you serve and the implications this has for your brand, where there's incidents of discrimination that is often unintended. There are many types of bias, but the most prevalent ones generally fall into 5 categories. So when we consider sample bias happens when the collected data doesn't accurately represent the environment the algorithm is expected to run in. So for example, if we think about security cameras, if your goal is to create a model that can operate security cameras at daytime and nighttime, but you train it only on nighttime data, you've introduced sample bias into your model. When we consider exclusion bias generally happens as a result of excluding features from one's dataset, usually under the umbrella of cleaning our data. Sometimes we delete features thinking that they are irrelevant to our outputs based on pre-existing beliefs, but they're actually very, very relevant. As we step across to observer bias, With observer bias, there's a tendency to see only what we want to see, right? So when a researcher studies a certain group, they usually come to an experiment with prior knowledge and subjective feelings about the group being studied. In other words, they come to the table with conscious or unconscious prejudices, and as a result, they've introduced bias into their research. As we move to prejudice bias happens as a result of cultural influences or stereotypes. If your goal is to detect people at work, your model has been fed thousands of training images where men are coding and women are cooking. The algorithm is likely to learn that coders are men and women are chefs, which is wrong since we know women can code and men can cook. The problem here is the data is consciously or unconsciously reflecting stereotypes. Think about nurses versus engineers as another classic example of this phenomena. A simple image search in a search engine will bring up a gender-skewed results for nurses and engineers. And then finally, measurement bias. So measurement bias is usually the systematic value distortion that happens when there's an issue with a device used to observe or measure the experiment at hand. This kind of bias tends to skew the data in one particular direction or the other. Think about false positive feedback loops on biased data. This is especially prevalent with drug prediction algorithms. If police get sent to neighborhoods where a lot of minority people live and make drug arrests, that data gets fed back into algorithm that in turn will make the algorithm predict more future drug arrests in those neighborhoods and send the police there again, even though there might be other neighborhoods with the same crimes, but because the data wasn't fed back into the algorithms from those neighborhoods, it then creates this false positive feedback loop that is not really reflective of reality. So why is bias so hard to fix? Well, we don't know what we don't know. The introduction of bias isn't always obvious during a model's creation because you may not realize the downstream impact of the data and the choices you've made until much later. And once you do, it is extremely hard to retroactively identify where that bias came from and then figure out how to get rid of it. Our processes are imperfect, so many of the standard practices in deep learning are not designed with bias detection in mind. Deep learning models are generally tested for performance and outcome success, and then they are deployed. Bias is often an afterthought, and it's only addressed when actually an incident occurs. Then there's the lack of social context, right? Context absolutely matters. We have different contexts when it comes to ethics, values, and fairness based on our unique lenses and our worldview. For example, notions of fairness and values differ across regions and geographies. In some cultures, we choose women and children's lives to be saved first before men. We have principles that say the needs of the many outweigh the needs of the few. We value life differently in the East than what we do in the West. So social context absolutely matters. And then there's this whole paradigm of ethics, values, and fairness. What's different about computer science is that the concept of fairness has to be defined in mathematical terms, like balancing the false positive and false negative rates of a prediction system. But as researchers have discovered, there are many different mathematical definitions of fairness that are mutually exclusive. So, for example, does fairness mean the same proportion of black and white individuals should get high-risk assessment scores, right? Or that the same level of risk should result in the same scores regardless of race. Another big challenge of data is whether it can actually give you ethics, right? How does data define the value of a relationship? How does it summarize the worth of someone I trust? How does it express the passion of feeling alive in a moment, or the rush of excitement, or the thrill of fear? So why do we have this situation in the field? AI learns to make decisions based on data, and that training data is laced with human bias, often reflecting historical or social inequities. And even when we try to compensate for it, the data often still misleads these AI algorithms. And this is not a vendor-specific problem, right? It is a field-specific problem. This is not an opinion either, it's a fact. The literature is very clear on this topic. Study after study supports these findings, and the empirical evidence associated to this is unquestioned. What we see is how even the most advanced tech companies out there with their based facial recognition algorithms still struggle with gender and racial bias. As an example, using limited data sets to build facial recognition technologies with images that don't represent satiety as a whole is a recipe for disaster, and ultimately will lead to a systemic erosion of trust in these technology solutions. And then we have those unintended consequences, right? Let's have a look at a few of those where algorithms have gone rogue. So, in June of this year, police in Detroit, USA were trying to figure out who stole 5 watches from a Shinola watch store. And so they pulled the security video that had recorded the incident. They zoomed in on the grainy footage and ran the suspect through a facial recognition system. A hit came back, 42-year-old Robin Williams of Michigan. So the police got a warrant for his arrest and promptly arrested him at his house in front of his family. Williams was detained, he was interrogated, and then he was released on bail until his hearing. That's when prosecutors actually dropped all charges against him. It turns out that Williams was misidentified by the algorithm the police used. Life can change very quickly in a holding cell. Imagine the impact of this at airports and terrorist watch lists as we see more and more airports embrace this type of technology. Then we hear a lot about how AI and robotics are transforming healthcare, which is a fantastic thing, but it comes at a cost. What we don't hear as much of is how bias in common healthcare algorithms disproportionately hurt Black patients. A recent study in the Science Journal found that a widely used AI algorithm that helps hospitals identify high-risk patients who could benefit most from access to special healthcare programs was racially biased. Black high-risk patients were roughly 50% less likely to receive access to special healthcare programs arising from chronic health problems like diabetes, anemia, and high blood pressure than white ones with the same criteria. And then we have privately developed machine learning algorithms that predict a defendant's likelihood to commit crimes, right? A recent study found that these algorithms were biased in its predictions about prisoners who were more likely to recommit crimes. It was found that the algorithm was 2 to 3 times more likely to incorrectly cite Black defendants as being high risk for recommitting crimes, and it was also 2 to 3 times more likely to incorrectly predict that white defendants were at a low risk to recommitting these crimes. This then led to skewed results in parole being granted and denied. And this algorithm is used by judges in over 12 US states. A subsequent study then showed that this AI algorithm was no more accurate at predictions made than people with little or no criminal justice experience. People that had no experience or expertise in criminal justice scored about 67%, and this algorithm was scoring at 65% accuracy. So how do we fix the situation? Well, one, we need to be aware, right? Be aware of the context in which AI can help correct for bias, as well as where there is a high risk that AI could exacerbate bias. Bias has to be part of the design process. We need to establish processes and practices that test for and mitigate bias in AI systems. We need to design algorithms with bias in mind as part of the design process and not as an afterthought. We need to acknowledge the human element, right? Engage in fact-based conversations about the potential of bias in our human decision-making system. And then we need to invest more in bias research. We need to make more data available for research while respecting privacy. And then we need to adopt a multidisciplinary approach to overcoming this. Diversity and inclusiveness matters absolutely in this exercise. We need to invest more in diversifying the AI field itself. A diverse view and a diverse perspective matters to AI success long term. So who decides? Who decides what we use and what we don't use? Which technologies get adopted and which do not? The hard truth is that as consumers, we ultimately decide. We do so by voting with our money and surfacing issues that matter in society when injustices occur. Yes, there are other role players like the data scientists, the tech companies, the data sets, regulators, lawmakers, academia. They all have their part to play, but ultimately, we as consumers decide. Think about a microwave. Who of you listening to me right now understands how microwave works well enough to build a commercially ready one? I would venture not that many. But who of you have not used a microwave? And why do we use something that we don't understand? Because you trust the outcomes. And with AI, it's no different. No technology solution can survive if their users don't trust their outcomes. Adoption will simply perish. So think about autonomous vehicles as another example, right? There are currently two schools of thought for how they should go about valuing human life. The one centers around consequentialism, advocated by Immanuel Kant, and the other one focuses on utilitarianism as advocated by Jeremy Bentham. If 90% of the cars produced operate by utilitarianism principles, but no one bought them, will those companies remain in business? Guess where they will be reinvesting their funds? This is what I mean when I say we as consumers actually decide. So what does our future look like potentially? Well, fixing bias and discrimination in AI is not something we can just solve overnight. Just like solving discrimination in any other part of society, it's a process. A strong contingent of AI researchers are working very hard to solve this problem. They've taken a variety of approaches, so algorithms that help detect and mitigate hidden biases within training data, or that mitigate the biases learned by the model regardless of the data quality, processes that hold companies accountable to the fairer outcomes, and discussions that hash out the different definitions of fairness. My personal view is that we should push for an entire new field to be created that focuses expressly on bias in AI algorithms. It's really that important. In fact, algorithms should probably go through the same process that new vaccines go through before entering society. Their effects, after all, are just as consequential, if not more. Ultimately, being fair and responsible in terms of AI has a price, and it's up to businesses and societies as a whole to decide what that price is and whether they're willing to pay for it or not. Thank you.